That's why we're turning to these workbook pages. But I need you to add some notes up at the top of these pages 88 and 89. On page 88, you are assigned all of the problems on page 88. But at the top of page 88, I want you to put on these notes so that it can help you. First off, this entire page only deals with perpendicular bisectors. This whole page is perpendicular bisectors. And we know that you can only have a perpendicular bisector for segments. It only works for segments. Can you bisect a line? No, because you have no idea where the midpoint is. It goes towards infinity in both directions and beyond. Can you bisect a ray? Same reasoning. Like, it does have one endpoint, but how do you know when you get to the midpoint? Like, you just keep going and going and going. So this only works for segments that it can be perpendicular and bisect a segment. Then, this is the most important thing, and this is what's going to help you solve these problems on page 88 of the workbook pages. Any point on the perpendicular bisector, any point on the perpendicular bisector is equidistant from the two endpoints of the segment that's being bisected. Any point that is on the perpendicular bisector, that point will be equidistant, meaning the same exact distance away, from the two endpoints of the segment that is being bisected. You will use this rule to help you solve a lot of these problems on this page. I'm going to do number one, the example with you. I'm just going to kind of show you what I mean by if a point is on the perpendicular bisector, then it's equidistant from the two endpoints of the segment. Now, for item one, it is extremely clear that segment BD is the perpendicular bisector. It won't always be this easy. It will not always be this easy. But they have now, number one, made it evidently clear that this segment BD truly is the perpendicular bisector. Now remember, we can extend these segments to make rays, or we can extend these to make lines. So this object here that contains point B and point D, that is the perpendicular bisector. If you want to keep it as a segment, wonderful. If you want to extend it, make it into a line, wonderful. But what this theorem tells us is that any point at all, doesn't matter where it is, as long as it's on this perpendicular bisector, it will be equidistant from the two endpoints of the segment that's being bisected. So, I know that there exists a point right there. A line is just a bunch of points, infinitely close. It's a collection of points. So, I know that the distance from that point on the perpendicular bisector to the two endpoints, it's going to be the exact same. It's equidistant. We can have a point way up here. The distance from that point that's on the perpendicular bisector to the point that, to the two endpoints, this will always be the same because it's equidistant. You can even go below the segment if you want. So what if we wanted to choose a point down here? That is on the perpendicular bisector. Well, it still works. The distance from that point to the two endpoints, that's going to be the same. It's equidistant. So, is point B on this perpendicular bisector?
Yes.
Absolutely. So what's true about segment AB and segment BC? Those two segments are congruent, therefore their lengths are equal. Okay, so that's what I mean by any point on the perpendicular bisector is equidistant from the two endpoints. So you're going to be using that to help you solve the problems on this page. Go to page 89. Flip it over to page 89. Now, stay there on 89. On this page that we just got done with, on 88, this only deals with one segment and its perpendicular bisector. We need to get to triangles that has 3 sides, 3 segments, and 3 perpendicular bisectors. So that's where this comes into play. This is the first diagram that has a triangle with its 3 perpendicular bisectors. All the other stuff was just one segment with one perpendicular bisector. The point of concurrency for the perpendicular bisectors is called the circumcenter. So up at the top, this page is still dealing with perpendicular bisectors, but you need to make a note that the point of concurrency, the POC, is the circumcenter. You have that in your textbook. You have that on your POC charts. This is everywhere, but if you want to go ahead and add it up top, that's perfect. What you need to write, this is absolutely necessary. You need to know that the circumcenter is equidistant from the triangle's vertices. When you locate that circumcenter, it will be the same exact distance away from all 3 vertices. It will be the same exact distance away from all 3 of the triangle's vertices. Alright, so on the previous page, what we wrote was that any point on the perpendicular bisector was equidistant from the 2 endpoints of the segment. Well, these are all segments, right? The sides of the triangles? These are all segments, okay? But when it's in this context with the triangle, what do we call those endpoints of the segments? Vertices, right? Vertices. Singular would be vertex, but plural is vertice. So, would you agree, does everyone agree, that the point of concurrency, the circumcenter, that circumcenter is on all 3 of the perpendicular bisectors? Right? Okay, so any point on the perpendicular bisector is equidistant from the 2 endpoints.
Yes.
That's why this point, the circumcenter, since it's on all 3 of the perpendicular bisectors, it's equidistant from all of those endpoints, which are just the triangle's vertices. Okay, that's the relationship between those 2 things that you wrote here on page 89 and then on page 88 as well. But you need to know that the circumcenter is equidistant from the 3 vertices to help you out with these problems right here. On this page, page 89, you are assigned 13 through 18. On that page, page 89, you are assigned 13 through 18. So go ahead and circle those problems. Now, the last thing that we'll do before we head out of here, and you guys won't see me until Tuesday. It's a long time. I miss you guys. It's on the Springboard textbook, page 198. Springboard textbook, page 198. This won't take too long, but we haven't discussed yet how to write the equations of these perpendicular bisectors. We've talked about them. We know what it means to be perpendicular. We know what it means to bisect something. And we know that its point of concurrency is the circumcenter, and we wrote down all that information about it. But now we need to make sure that we can write the equations of these special segments. Now, I don't care what's going on this page. Apparently, Al, who likes algebra, and his bud Jeff, that spells his weird name, or he spells his name weird, and apparently there's a guy named Cal. I don't care what they're doing in this grand adventure of finding treasure and whatever. We're just going to use this diagram, and we're going to write the equations of the perpendicular bisectors. Okay? So don't read what's happening around you, because I have not wasted my time. This is just a convenient place to write some equations of perpendicular bisectors. So, if you want to go ahead and write that up top, that'd be great. Right here, what we're doing is equations of perpendicular bisectors. Okay, on your chart, on that point of concurrency chart, you have the definition written down. So we're not going to waste our time right now writing it over again. Well, let's just use these segments named to help us figure out how we're going to write these equations, right? Because we need the slope and we need a point that it must go through. We need the slope of this line and a point that it must go through. Let's knock out the point first. These are perpendicular bisectors. They are, they only work for segments. We know that a triangle has 3 segments. Those are your 3 sides. So just based off of the name, what point must these perpendicular bisectors go through?
Midpoint.
Has to go through the midpoint. Okay, so just by the name, we know that that is one point that these perpendicular bisectors have to go through, are the midpoints. Let's quickly find the midpoints of each side. The first one would be 612. This one would be 18, and this one, blue. Alright, those are our 3 midpoints. We got 612, 2412, and 180. We agree? Alright, so you are using the midpoint formula, but remember, you're just taking the averages. So the average of 12 and 0 is 6, and the average of 24 and 0 is 12. That's how I'm doing it in my head. But these are the midpoints. Now, so we have one point that it goes through, that each one of these perpendicular bisectors go through. Now, we need to figure out something about the slope. Well, the other word in its name tells us about the slope. These special segments need to be perpendicular to the segment that it's bisecting. So it's got to be perpendicular to the segment that it's bisecting. What's bisecting? The triangle sides. So we need to find the slope of all of the triangle sides. Segment AC, its slope is, obviously it's positive. It's a positive 2, correct? So the slope that would be perpendicular to it would be a negative 1/2. The slope of segment CG is a negative value. It's negative 1. I can clearly see that it's negative. And when you use the slope formula, it comes out to be negative 1. So the perpendicular slope would be what?
1.
Positive 1. What's the slope of segment AG? 0. What would be the slope that's perpendicular to it?
Undefined.
Undefined. You gotta warm up full of this stuff. Now, we have a point that it goes through and the slope of this line. Can you write the equations of these? Absolutely. The first one would be y minus 12 is equal to negative 1/2 x minus 6. And when you simplify this, you're going to get y is equal to negative 1/2 x plus 9. After you distribute, and then you add 12 on both sides, you will get y is equal to negative 1/2 x plus, nope, bad, wrong, 15. What are y'all getting?
Numbers.
Numbers.
1/2 x, negative 1/2 x plus 15?
Yeah. Yeah.
Wunderbar. And then, so this is only one of them. And then you can find the equations of other ones. Like for instance, this one's going to be x is equal to 18. That one's pretty easy. The x equals 18. Well, once you have x, you can plug it in here. Negative 1/2 of positive 18 is negative 9. Plus 15 gives you 6. So I know that this circumcenter would be at 18, positive 6. And this equation over here would be y is equal to x plus 12. Nope. Minus 12.